Hi all, and welcome to our online version of EMEC245. It's not the best way to present this material, but under these circumstances, we got to try to get through, and do what we can do. I hope you all were able to download and install the Rockwell CCW, because that would be the best thing that could happen, because we can do a whole lot of stuff with CCW online, and including having you create HMI screens, and it's free. So I hope you're able to do that, or were able to do that. If you were not, you'll be doing other things like discussion boards and chats and stuff like that to get through the course. That said, let's take a look at what you would have been doing in Lab 6. Now, I covered a little bit of this, I think, the last time I saw you. But anyway, Lab 6 is called a furnace with a simple thermostat. And Lab 6 was going to have your first control scheme. In other words, it was going to be the first program you did that actually performs some control. And in this case, it was only going to be controlling the heater. So there's two modes on the heater. There's an auto and a manual. And in manual mode, you'd still turn the heater on and off by hand. In auto mode, the heater will turn on and off automatically based on something called a set point. The fan also has the fan will only be manually controlled in this program, just with a switch, cooling or not cooling. What you are going to be asked to do in this lab is collect some data. And you are going to collect some data about how long does it take to get to the set point, how long does it have overshoot, how long is there undershoot. You were collecting data that we could use, especially when we get to Lab 9, which is the PID lab. So I'm going to do something that I actually did on the whiteboard. I don't remember when it was anymore. It was at least 2 or 3 weeks ago. I'm not very good with this electronic pen yet, so, we can laugh together. So I had this on the whiteboard where we have these axes. And this is our time, and this is the process variable. And we talked about process variable. So we've already talked about some terms. We've talked about the process variable. We've talked about the engineering units. Today, I'm going to add another term, and that term is set point. And we're going to have that identified as SP. This will be set point. And the set point is nothing more than a user-defined point as to where you want your control system to control. So just like in your home heating system, you go over and you set your thermostat, and where you set the thermostat, that's called the set point. So on this graph, we're going to add a set point. And let me add a set point. My pen didn't change color. There we go. So we'll add a set point. And this will then be, let's say this is 100 degrees. And this will be room ambient down here. So when we turn on the heater, or when the heater turns on, the heat will start ramping up. It'll start ramping up, and when it gets to set point, the heater will turn off. Now, there are dynamics in the system. Just because the heater turned off doesn't mean there's not going to be any heat generated, because that heat doesn't immediately stop radiating off the heaters. So you're going to experience what's called overshoot, and this is called overshoot. The heater's not on, so it eventually will cool down. And when it gets below the set point, or just below the set point, the heater will turn on. But again, the heater's not going to heat up to its full capacity right away. So the dynamics in the system says that this is going to continue cooling down until the heater catches up. It'll then come back to set point, the heater turns off, the dynamics drive it over. And what happens is it oscillates around the set point. So we have overshoot and we have something called undershoot, which is this area. What I was going to have you do in the lab was measure the amount of time that it took to get to the set point. I was going to have you measure the amount of overshoot, the amount of undershoot, and how long it took to recover from overshoot and undershoot. So recovery time. All this was going to be a data collection lab, because you could also then determine the frequency of this overshoot and undershoot, as far as how long does it take, how often does it occur, how long does my process take to heat up. This was just for data collection to make Lab 9 a little bit more meaningful. Even though you could do Lab 9 without this data would help you tune the system when we go to a full-blown control system. All right, so that said, what I'm going to have you do is a discussion on Lab 6, and I'm going to ask you to analyze the program. Yeah, I know the discussion, analyzing programs is not your favorite thing to do. But anyway, in Chapter 14 of your textbook, and you have access to the textbook online. If you don't have the text in paper format, Chapter 14 is online. It's in Blackboard. And Chapter 14 talks about intermittent and continuous process control. I would like you to look at the program code and determine what type of control is this. Is it intermittent control? And if so, there's 3 categories under intermittent control. Is it continuous control? And there's 4 categories under intermittent control. So you're going to classify what type of control system is the program performing. And then I'm going to have you analyze the entire program, describe the full operation of that program from start to finish, just as if you were the processor scanning that program. All right, so I'll put what I just said in text in the discussion board, so you don't have to remember that. But this will be one of our assignments. Hopefully you were all able to get the CCW software downloaded and installed, because if you did, wow, we've got enough material to cover just with that for the rest of the semester, and you'll be able to create HMI screens with CCW. So, hey, let's get through this. I hope you're all safe. Please stay safe, stay smart, keep your social distance, and hopefully we can get back on campus before the end of the semester. So I'll see you online, and I'll be online every day for sure, because where am I going? All right. Anyway, hey, thanks, and check your discussion board and the weekly learning content. See ya.